Assalamu alaikum. Hello everyone. Today's our this is our eighth class. It should be actually the fourth one, but yeah, it's delayed. This is our this is our eighth or fourth class, whatever you want to call it. And today's goals are going to be how load address is written from a pseudocode to basic two codes, and how load word is taken, like load word and load address are pseudocodes, and we're just gonna explore and learn how are they made of two codes or basic codes. So let's get started. So starting with load address, basically I said it's a pseudocode, and what we do is we take the address of this word and then we load it to register A0. And when you execute or assemble the current file and clear breakpoints, right? When you execute it, you're gonna see two codes which are load immediate, load upper immediate, and then or immediate. And as you can see here, this is the source. So basically load address is made of these two codes. And today I'm going to explain how are they made of these two codes, since it's very important to know. All right, so as you can see here, here is load address A0 word, which is take the address of word and put it in A0, right? And here are the two codes that load address are made of, load upper immediate or immediate. So basically, let's just start it. What do we do in the beginning? We first take the first 4 bytes of the address, right? Or like we just take the upper 4 bytes of the address, which is 0x1001. As you can see here, the data starts from 0x1001, and the rest 4 bits at the end are zeros. So we said the first step is to take the first 4 bytes of the address, which are 1001, and yep, that's basically how it is. Of course, maybe in the exam or the midterm, they will tell you that the data is some another number. So you need to know and you need to understand that this might change in terms of exams and quizzes. But like for now, the program is fixed, so we're just gonna take the first 4 bytes, upper 4 bytes, right, which is 1001, and as you can see, it's here 1001, and then you're gonna take this 0x1001 and put it in 80. So basically, 80 is just a temporary. It's not like temporary registers. No, temporary registers can hold a value, store a value, but like 80 is a helping register. You can say that it's a helping register. You use it, like mostly it's used to form pseudocodes. Sorry, to break the pseudocode into basic codes, and we use it in order to do what the pseudocodes does in 2 or 3 codes. So you can just say it's a temporary for just this pseudocode right now, for now, right? So basically, you take this, as we said earlier, take the 4 bytes of the address and then you put it in 80. And then we do the following. We just write or immediate. So this is load upper immediate. So 80 right now is, wait, let me write this. All right. So load upper immediate means load the first 4 bytes into the upper 4 bytes of 80, which is the temporary, and basically we're just gonna copy these 4 bytes, 1 2 3 4. So here 1 0 0 0 1, right? And now we have 0 0 0 0, and we deal with them in the or immediate. So basically here it says or I A0 AT 0x00c. Basically this is or immediate, so it says or immediate this number, which is this address, which is 0x00c and 80. And since it's not load upper immediate, we start from the least significant bit, which is from right to left. But load upper immediate, it's like you go against the rule, or like it does something for you. So basically it just changes the upper 4 bits, right? Upper 4 bytes. So basically, normally when you and or I, you just change from the beginning, from the least significant bit to the most significant bit, which is, this is the most significant bit. Wait, let me write it in a different color. This is the least significant bit, and this is the most significant bit. So basically we go from right to left, right? But since load upper immediate is a code, so, or like you can say it's an instruction, it does what you want. So it load upper immediate the first 4 bytes. I said this over like 5 times right now. Let's go to the work. So basically we're gonna have what's inside 80, and this is it, 0x10010000, and then we're just gonna have this 0x00c. So basically it's gonna be like this, 0x00c. Oh yeah. And then you might be wondering, uh, this is not the same number. So basically what we're gonna do, we're just gonna extend it with zero sign extension, right? So I think it's not a I think it's a sign extension or zero extension. I don't really remember. But basically we're just gonna add 4 bytes in the beginning as well in order to match the numbers. So basically when you wanna add, like, wait, when you wanna add 100 plus 1, it's literally the same as 100 plus 100, right? So basically the answer is gonna be 101. And this is what we're gonna do right now. We're just gonna go here, and then we're just gonna add the 4 bytes in order to make it like 8 bytes, which means 32 bits. 1, 2, 3, 4, and then just, okay, cool. So let me get rid of this, right? Yeah, take this as well, and then the answer is gonna be, yeah, it says or immediate, right? It says or immediate, and you know or immediate is like or gate, which means when you see anything with a zero, just put the answer of the anything. So if they're both zeros, just keep it as zeros. If there is 1 0, the answer is 1. So basically we're starting from here, right? Yeah. Okay, cool. So 1 0 is gonna be 1, 0 0 is gonna be 0, and you understand the rest. So it's 1001, and then 4 zeros and 3 zeros and C are like 000C. And yep, that's going to be the answer of the operation or immediate 80 and 0x00c. And you take all of this address and you put it in A0, since this is what the data sheet says, green mips, green sheet, as I told you. So now A0 is going to contain the address, which is the same as Word, and you're now done. Basically now you loaded the address of Word to A0. Well, how do you know that the address is gonna be 0x1001? We said it's from the program. Maybe in the quiz they give it to you. Maybe in the quiz they give you the answer, right? They give you the address. But what about this one? This is this, like, okay, at least you understand that, like, the first 4 bytes you take it from the data section, which is 1001, but like the rest are 0000. So how do you know that it is 000c? And basically, um, it's not obvious, but here is how it goes. So first of all, I have what comes first in the data section is array, right? And array starts from, um, where is the array? We said it's text, right? So it starts from 004000. Is it a text or data segment? Oh wait, it's a data segment. Yeah, so we're in data. Sorry. So basically, we start from 1001000, right? So basically, this array starts from 1001000, right? And this is the location of its first word. So what about the second word? The second word is gonna be 10010004. Why? Because we go 4 bytes. No, sorry, we go plus 4 bytes. Yeah, I guess so. But like, all you need to know that this four, like, from a word to another word, you just add 4, right? So basically 5 to 10 is another 4, and 20 is gonna be 10010008. So what about this one? Yep, you're just gonna add 4, but like, make sure it's in hexadecimal. So it's gonna be 10010000, and then you add a C, because 8 plus 4 is 12, and 12 in hexadecimal is C. And what are the least 4 bytes? They're gonna be 00C, and it's literally the same as this. And this is how you make load address A0, load address into normal codes, or like normal instructions. And that's for load address. Now we go for load word. Oh, just before we go to load word, I just realized something. I didn't explain this correctly. So basically, when you or, okay, let's say when you or two numbers, right? You're just gonna take with a different color, yeah, and different thickness. Mm-hmm. You're just gonna take one bit with one bit and compare it. Whatever is not to zero, just put it. So 1 0, we have 1. Both of them are 0, so you put 0. And then as you can see here, 0 and C, we just put C. And that's it. All right, now we are dealing with load word, and I want to tell you guys that load word is not always a pseudocode. There are types of load words that are not pseudocodes, which is like basic instructions, and there are types of load words that are pseudocodes. So if we execute, as you can see, we have two codes: load word T1 for T2, and this basically load the word from T2 if it's an array or an address or a word. Like we don't know anything. It's just an example, so you don't need to understand the code, but like you need to just like I'm gonna explain it. So basically, you're taking the address of T2 and you add 4 bytes to it. So if it's an array, it goes to the next. So if T2 in the first data of the array, when you add 4 to it, it just goes to the second data, right? So now you are in I equals 1, and you basically put it to T1. And when you execute it, as you can see here, it's just one line of code, which means like load word. So basically, you're just gonna take the address of this, you're gonna add it to register 10, which is T1, and then you're gonna give it to register 9, which is T. Oh, sorry, register 10 is T2, and register 1 is T register 9 is T1. So this is not a pseudocode, and it's a basic code, and my intention for today is just teaching pseudocode, so I'm just gonna delete this. And now we're gonna deal with load word T2 array, which basically take the array and put it in T2, or like put everything that's inside the array into T2. So you just can do this, right? Maybe you don't want an array, you want a fixed array, so you can just write dot word and then 5 10 20, like the previous example of load address, right? And when you do this, now you're gonna load the array into T2, and when you print T2, I guess T2 is gonna be 5 because the first element of T2 is 5. As you can see here, it's made of two codes, load upper immediate and load word. So let me take them and teach them in the Miro program. All right, so now we're ready. So basically, this is pseudocode, and this pseudocode is made of two basic codes, which are load upper immediate and load word. I told you load word is not always a pseudocode, right? And I showed you an example like 5 seconds ago. So yeah, this load word is actually uh, a basic instruction, so no need to worry. All right, so let's start explaining. So the first step of load word is also load upper immediate AT, which is the temporary register 0x1001. So you can also say that load word and load address share the same first step, which is load upper immediate, the temporary, and the first 4 bytes of the address, which is I guess most of the time 0x1001, right? Let me change the thickness. Okay, cool. Now it's different because remember in load address we had ORI, but this one is not ORI anymore. We use load word, and here's what we load. So basically, we just take the first 4 bytes of the address. So not the first 4 bytes, sorry, the last 4 bytes. So this is like the first four um, bytes, which are like, so basically our address of the data is 0x10010000, right? So basically, we just take this 4 and then we put it here, which is pretty simple and easy. And then what do we do next? We take these 4. Sorry, that's a weird color. Gray is good. Yeah, we take these 4, which are 0000, and then we put it here in front of 80. So 80 is actually this one right now, and then we add this. So what does this mean? This mean take the 80 and then plus it with this one. So the answer is gonna be, I'm gonna write the answer here. So the 80 is 1001, so I'm gonna make it in this color, 10x1001, and then with a different color, give me the magenta, we have 0000, which is 0000. And now after you take all, oh wait, with a different color now. And now when you take all of this address, just put it in T's. Oh, this one should be T2. My bad. This one should be T2. It shouldn't be T0. Why? Because as you can see here, we want to take the array and we want to store it in T2, right? But what I did is I take it and I store it in T0, and this is not how the compiler, like this won't compile because this T2 and this also should be T2 because this is our result. So basically just imagine that this is T2 and then you just put it over there. Now, why is this 0, 0, 0, 0? Because remember, the first word is always 0x in the address 0x1, 0, 0, 1, and then 0, 0, 0, 0, and then you go 4 bytes, right? You go 4 bytes. So this is gonna be um, the same thing as this, but change this 0 to 4. So it's gonna be 0x1, 0, 0, 1, 0, 0, 4. And this is the address of 10. And go and so on. So basically, let's say this is not array anymore, and this is like word, right? And then I have like a word here in the data segment, and it is 10. So basically, this is 4, this is 8. So this is gonna be 0x1001000 0 C, and this also 0 because like it should be 4. 1 2 3 4 1 2 3 4. Yeah. So basically now I want to load word to T2. So basically now this is gonna be 0 0 0, and this should be C, right? This should be C, and so basically this is not gonna be 0 anymore. This is gonna be C. Like this part at least is gonna be C, and then we just do the the plus thingy, which is here 80, and here the address we have 0x000c, and then we get the answer 1001 000, and then we just delete this and we put C, and then we give it to the register we had in the beginning, which is T2. So basically this should be T2, not T0. That's for today. I hope you have learned. Thank you so much. Enjoy your day.